Hello and welcome to helpyourmath.com. In this video, we're going to take a look at evaluating composite functions with numeric inputs. First, what is a composite function? A composite function is when you create a function by inputting one function into another. The notation that we use is we say f of g of x is equal to f of g of x. So this little guy here, when we see that, it means of. Notice that it really does look like the multiplication sign, but it does have that open center. That's how you know the difference between when it's a composite function versus when it's multiplication. Composite functions are not commutative. So what that means is that if we have f of g of x, this is not necessarily the same thing as g of f of x. That's all that means. So it's not necessarily commutative. We could get two different answers. When we are given a value to plug in, we plug it into the inner function. The inner function is always the one that's like on the inside, right? So when we rewrite it, we would plug it in here to g. Then its output is the input for the outer function. Be careful of the restrictions on the domain of the composite function. The domain of a composite function consists of the set of real numbers that are defined in g and on which g is in the domain of f. Let's take a look at some examples. We want to evaluate f of g of 7, given f of x is equal to 6 minus x, and g of x is equal to the square root of 2 plus x. So the first thing we want to do is let's just rewrite it. This would be f of g of 7, and now we want to evaluate g of 7. So g of 7, that just means anywhere in g that I see an x, I'm going to replace it with a 7. So this would be f of the square root of 2 plus 7. The square root of 2 plus 7, well 2 plus 7 is 9, so we have the square root of 9. The square root of 9 is 3. So now what we want to do is we want to evaluate f of 3. Notice I just went through the steps for calculating or evaluating g of 7, and the output was 3, so 3 is now the input for f. f of 3, that means anywhere in f that I see an x, I'm going to replace it with 3. I have 6 minus 3. So we end up with 3. So we could say that f of g of 7 is equal to positive 3. Let's look at another example. Here we want to evaluate g of f of 6. So remember what this means, g of f of 6. And we're given f of x and we're given g of x. I do notice that g of x, we will have some issues with its domain. It is a rational function, which means we could have some things that don't work in its domain. Let's talk about that when we get there. Or if we need to talk about it, we can talk about it when we get there. Starting with f of 6, we're going to work with this inner function. I want to calculate f of 6. That means anywhere I see an x in f, I'm replacing it with 6. So this would give me g of, and this would be 6 squared minus 8 times 6. Let's try that again. 8 times 6, there we go. 6 squared is 36. 8 times 6 is 48, so we have g of 36 minus 48. This would be g of negative 12. Okay, so now what happens when we calculate g of negative 12? Anywhere in this function, I see an x, I'm going to replace it with negative 12. In the numerator, I get negative 12 minus 4 over, down here I get negative 12 quantity squared plus 8 times negative 12 minus 48, and that's going to give me negative 16 over, that's going to be positive 144, minus 8 times negative 12 is 96, or negative 96, minus 48, I think I have a problem here, because this adds up to negative 144, so what does this mean? This meant we had some issues. This meant that 6 couldn't have been in the domain, because it led to an output that wasn't possible, right? So if we look at g, we get x minus plus 12 times x minus 4. Yep, there it is. X can't equal negative 12. X can't equal positive 4. So because we did have something that led to restriction on the domain, we can safely say that this particular composite function cannot be calculated at 6. There is no solution. We can say no solution or empty set, something like that. If it had asked us to find the domain, we might have realized that earlier, but we did the work, we found out, whoops, not going to happen, no solution. Let's look at one more example. We want to evaluate h of negative 3 And there we are, we're given h of x is equal to x cubed minus 7x plus 2. So the first thing I might do is rewrite our composite function into something that looks a little more friendly. So we're going to say h of negative 3. And again, I start from the inside. So I don't really worry about what's outside. I just focus on h of negative 3. H of negative 3 means anywhere in the function I see a negative 3. I see an x, I'm going to replace it with negative 3. So this would give me negative 3 cubed minus 7 times negative 3 plus 2. Okay, so just working inside the parentheses, negative 3 cubed is negative 27. Negative 7 times negative 3 is positive 21 plus 2. So now we have h of, this would be 23. Negative 27 plus 23 is negative 4. Okay, so now what are we looking at? We're looking at h of negative 4. This time, anywhere in the function I see an x, I replace it with negative 4. So I'm going to come up here, say that h of negative 4 is equal to negative 4 cubed minus 7 times negative 4 plus 2. Negative 4 cubed is negative 64. And negative 7 times negative 4 is positive 28 plus 2. These two positives make a 30. So we have negative 64 plus 30. That's going to give me negative 34. Good thing I don't have to plug this in again because that would be a huge number to have to cube. So there we have it. We have h of negative 3 is equal to negative 34. These have been examples of plugging in numbers into composite functions. Thank you for stopping by.